Okay, today we're going to take a look at 12J, which is variance and standard deviation. And so our first uh, formula is population variance. And this symbol right here, the alpha symbol or sigma symbol, um, is how we describe variance. And it is the squared, and mu is the population mean, and n is the number of data sets. So looks super confusing. I'm going to show you how to do it by hand so that it is not doesn't look as confusing as that. So, but that is your formula that you will see. And what is the purpose of population variance? So it essentially helps you determine the spread of your data. And how far away your points are from the mean. And by taking the square root of the population variation, we end up with what we call the standard deviation. And so, standard deviation, and in this textbook, we use SN. On your calculator for standard deviation, you're going to see it written like this. So that's the standard deviation you're going to be using on your calculator when you run the one bar stats. So it's essentially like if you look at the underneath of the square root, that is your population variance, and it is just a way to measure the dispersion of the data. And it's essentially telling you how far on average the data is from the mean. And so we sometimes call the standard deviation the average of the average. So let's just take a look at actually, let's talk about this first. Forgot about this slide, sorry. Um, Standard deviation isn't always your best option to describe the distribution of the data. So just remember that if you want to use standard deviation, then your data should be symmetrical or really close to being symmetrical. If it is skewed at any point, then you're going to want to use the IQR and your percentiles to describe that distribution of your data. So if it's not a symmetrical set of data, standard deviation is not your best option. Okay, so now let's take a look at our standard deviation and let's walk through one together. So what I do is I put it into a table. So we have our values x, and then we're going to have to do x minus the mean, and then we're going to have to take our x minus our means and square it. So those are what's going to be in this table. So the first thing I'm going to do is just rewrite my numbers. I have 2, 5, 4, 6, 7, 5, and 6. And step one is we want to find the mean. So you're adding all of these numbers up together, and there are 7 of them. So you add them up and divide by 7, and we get a mean of 5. That's step one. Step two is now we want to take each of our numbers in the set and subtract it from the mean. So I'm going to do like 2 minus 5, and I get negative 3. And I'm going to continue that. So 5 minus 5, I get 0. 4 minus 5, I get negative 1. 6 minus 5, I get 1. 7 minus 5, I get 2. 5 minus 5 is 0. 6 minus 5 is 1. And then these numbers that we have in this column, we want to square them. And the purpose of squaring them is so that we don't have negative numbers. So this gives me 9, 0, 1. 1 squared is 1, 2 squared is 4, 0 squared is 0, 1 squared is 1. And then we need to find the sum of these values here. And so the sum of these, when I add them together, is 16. So then our standard deviation is going to be first to find our population variance, which is our 16. It's going to be the sum of that last column divided by the number of values we have, because it's really just finding an average of those squares. So we're going to divide it by 7. And rounded 3 sig fig, we get 2.29. So our population variance is 2.29. And then to find our standard deviation, all we got to do is take the square root of that value. So I would recommend, if you're doing it by hand, that you take the square root of the entire fraction, 16 over 7, instead of doing that, because that's going to give you a more accurate answer. So my standard deviation, and I'm using this instead of the S sub n, just because that's what your calculator shows. So standard deviation, you can also see it written with the S sub n. But I end up getting 1.51. And there is my standard deviation. And you can run your one bar stats. If you plugged this list into L1 and ran your one bar stats, your standard deviation is going to be